Right. I think that's like the start gun for academia. Right. So thank you everyone for joining. And firstly, I think I speak on behalf of both Jen and myself that, Olga and everyone from the LS units in Graz, thank you for the opportunity to speak at your reading group. I'm personally delighted and humbled for the invitation. So the purpose of today's talk, so hopefully I won't take too much of your time, but I wanted to talk about our work here called Panza, the design analysis of a fully local personalized text writing assistant. This was work, as mentioned, that I did during my internship at ISTA. But instead of just speaking about the paper itself, I wanted to sort of take a more philosophical approach and actually talk about some of the really important ideas that come out of this single academic work. So the first thing that I want to mention and sort of make the argument for is that we really need personalized LLMs. And there are two axes that we can sort of view this necessity for. So the first is like a very obvious privacy preserving one. And the second one is an efficiency question. And once we've sort of laid down the groundwork for this, I'm going to actually talk about Panza as a specific use case into this investigation in a specific domain. But then once we've done this, I'm actually going to talk about something that I call the good, bad, and the ugly. And we notice that these sort of personalized text generation is very cool and very useful. But as we point out in our position paper, it is actually the time now to act on the considerable risk that these technologies pose, and they're not trivially solved. So generally, the presentation that I'm going to give today is going to be a merge of these two papers because the ideas are very linked and they influence one another. But before I begin, I just want to say a thank you to all of the collaborators that were involved in this project. So you can see their names here on the papers. I've cut Jen's and Dan's name on the second paper, but they're in the first one as well. And it's just to say that, even though Jen and I are here presenting the paper, it's not our work alone. And all of the work that has been done behind the scenes really make this project possible. So a big thank you to them. Right. So this is generally how I view typical LLM interaction today. So I got Claude to generate this, so thank you, Claude. But how it basically starts off is that you as your user at your laptop log in to your favorite LLM provider. So say it's Claude or ChatGPT. You log on and you type a prompt into the chat box and you send your message, and this message then goes into the nether and it hits some server where inference is performed and the response is sent back to you over the internet. And generally, this is like very, very cool because it's scalable. Lots of individuals and users can access it, and we see this, being very prolific. And it's also quite amenable to a large number of use cases that people want to use LLMs for. So if you want to, say, ask for recommendations of where to go on your next holiday destination, or if you want a quick and easy recipe of banana bread, LLMs are sort of your go-to source. It sort of simplifies a lot of this process that we had where we were searching through lots of pages on Google search, and it gives you something that is quite automatic. But the problem I guess I have with this is that this type of model of interacting through an API is not really sustainable if we want to sort of carry on with this level of LLM usage. And there are three chief reasons I think this is the case. So the first reason is that what happens when you want to process private information? So in the first case where I'm asking to generate a recipe of banana bread, I don't really imagine this is going to be particularly sensitive unless I'm quite interesting in my choice of ingredients. But if I say I want to ask an LLM to process or give me advice on how I should file my taxes, this is going to be much more sensitive and not necessarily something I want to send to an open server. There might be T's and C's that sort of restrict what my information can and how this can be used. But at the end of the day, the moment I click enter and this piece of information leaves my internal network, I have no control of how this will be used and whether it will be used for the wrong purpose. So that's the first reason. The second reason is that, these models are very capable, but they don't come without a fixed cost. So you can, of course, pay for a model on a per request basis, or some of my colleagues, they actually pay for the $200 a month max version of Claude. And in a world where the prices of these models like continue increasing, so you have to pay more to get models of better quality, there is going to be some point where the token economics no longer makes sense for the majority of users. So at least personally, I don't think I would be particularly willing to spend $1,000 a month just to access a model that may or may not be correct on a certain use case that I'm having. Now, the final part is, whilst these LLMs are very good and powerful, and it's quite remarkable that they're able to generate coherent text, that that's the first thing that they can do. What is a particular gripe of mine is that I often find myself rewriting the output that I get from an LLM. So it's very obvious to tell when a piece of text is LLM generated, and I actually have to go through quite a laborious process of rejigging the content and using synonyms to actually match what I would have said in my own style and language. And there is also a spectrum here that if I'm editing 90% of the output or even more, for example, it doesn't really make much sense in my use case to be using an LLM. So this is sort of the three reasons that we see to be the case here. And as a solution, the most basic way we can address a lot of these things is like, okay, let's just host our personalized LLMs at home, and it can actually hit all these three qualities if we do it correctly. So what has been solved already? So thankfully, I think it has never been a greater time to actually try adopt this LLM at home usage, because there's been a considerable investment in terms of, both software and hardware efforts, thanks to people like, building the VLM, Olama, and EXO frameworks. It's really, available to you as a user. You can download the software and you can just use it in one shot. And if you do this and you actually invest a slight amount of overhead capital to buy a couple of, say, Mac Minis or Mac Studios, you get this two birds with one stone scenario that, of course, you get privacy off the bat because your content is not leaving your internal network, and this is great. And you also solve this token economic question that the moment you sort of break even of this initial capital investment, you sort of win in this argument, and you no longer have to rely on fluctuating price models or fluctuating availability. You always have something that works. And also with open source models increasing in quality and catching up to those closed source models, this becomes even more compelling as an argument. But the problem of personalization, this is not entirely solved, and it's also a very fuzzy idea in itself, because we don't really know what it means to be personalized as a model, and what we should do to personalize a model. Is it sufficient to add something into the prompt that we send to the model? Is it sufficient to guide it with some markdown files and the context? Or do we need something much more technically involved to produce something that is useful to us as a unique user, that it adapts to our style? So this is where Panza comes in with our great logo. And Panza itself, in my view, the way I view it, is it has a dual purpose. So the first purpose it has is it has this sort of general market appeal to the user, where we wanted to create a framework for individuals to produce their own custom and style aligned LLMs on the cheap. So it is as simple as you downloading the GitHub repository, getting access to some GPU. It can even be a Google Colab instance or a Lightning AI notebook, because we've designed it for this purpose, and then running our scripts and producing a model for yourself. So this, in terms of itself, is this sort of framework and product version that we see. But the second question of Panza is it's more acting as an sort of academic article or an academic piece of writing, where we're trying to find what the continuum, what the limits of style transfer are. So what we want to know is, when does style transfer work, when it doesn't, and what we need to make it work, and how intensive this process needs to be to make something that is of a good quality that users will want. Now, the particular domain in which Panza rests, even though it's generally applicable to a larger domain set, is it's on email generation. And there are two reasons for this. So the first one is data availability. So ignoring the fact that leak emails exist widely on the dark web, and we could use this, there is a corpus of sort of samples on email generation where we have unique users and their unique email transcripts such that we can actually create this data set of style-aligned outputs per user, which was sort of needed in our study of Panza. So that's the first reason. The second reason is that there is a simultaneous relative simplicity and difficulty of the task. So whilst there is prior work doing this like style investigation, their generations are generally small. So what they try to do, for example, is email subject line generation. And I mean, of course, this can be stylized to an extent, but the output of a email subject line is relatively concise. It's a couple of words. I'm not going to put the entire like subject matter and like the content into my subject line. I'm going to use the body for this. So that's the first thing. We want to focus on actual email generation because it's much more difficult than these shorter prior works. But also, it is relatively simple because emails themselves, unless you're encoding entire legal documents into them, won't extend more than, say, 2 or 3 paragraphs. And it gives us a very neat testing ground without going into a scenario of, please generate my entire PhD first year report with a model, which I mean, I would love for that to be the case, but I think it's quite unlikely given this current scenario. But yes, so this is why we focus on email generation. And how we think of like Panza working is that Panza is basically going to be a model that lives on your local machine here on the left. And through using some sort of local web server, you can feed into it a prompt of an email that you received. So write an email to Jen thanking her for the coffee. Then Panza will output, hi Jane, thanks for the coffee. I really enjoyed it, Joe. And this integrates, say, directly with your Gmail with an extension that you can actually produce outputs to emails with one click. And this is, again, how we've tied the academic investigation and the product into one investigation. So Panza, beyond being this framework, is actually a very simple procedure, and most of it is sort of encompassed in this single diagram. So to walk you through it, how you start off with is you first gather some sort of user email history that you want to use to specialize the model. So this could be, say, your professional emails if you want this email to be used just for professional academic purposes, for example, or you could use it for your personal emails. It doesn't really matter. But the point is that once you've established all the emails that you want to feed into an LLM, you take this and you give it to an LLM for a process called reverse instructions. So what you're basically asking the LLM to do is, given the email output that was received, can it generate a prompt that would have likely produced that email response? And what basically this does is it creates a data set of all the emails that you had, but in a sort of prompt response format that can be used for fine-tuning. So this is very necessary because we need to have some structure in this fine-tuning, and it can't be autoregressive. What we simultaneously do is we take the initial email history that we had, and using an embedding model, we embed it into a vector database. And this is important, say, in generation, where if we're responding to a very long email chain and we want to use the initial emails as context to guide the generation, we can do so through some vector search. And this is known as, of course, as retrieval augmented generation, but just mapped into this email setting. Now, once we've established all of this, we go through some fine-tuning process. Now, with Panza, this can be the same LLM that was used to generate the training data set. It doesn't have to be. It can be any model, of course. But you go through some process of fine-tuning. This can be full fine-tuning or something that is parameter efficient, which we'll discuss later. But once you go through this process, you have your Panza mail model, and now you can use it for all of your generation purposes. You can plug it in with your favorite inference framework like Ollama, say on your Mac, and you can use it. Great. So the point of this is that I mentioned before that we wanted this to be very usable for individuals. And when Panza was designed, efficiency was really placed as a first-class citizen because we didn't want it to be a case of, oh, you can do all of this personalization, but you need like H100s to train the model to get it done. Because I don't know many people that are willing to fork out, say, £25,000 to buy a single H100. So what we had in mind is to actually focus on these like consumer cards that have, of course, a realistic GPU memory and that is have a capped memory footprint that they can have. But it is a much more realistic setting to what individuals might have access to. So you will find these GPUs in gaming laptops and they're readily available in the consumer market. Or in the case of notebooks online, such as Lightning AI or Google Colab, this is something you can leverage for yourself if you don't have your own GPU locally. Now, the experiments were conducted in two settings. So the first scenario are ones that are inspired by this, hypothetical 24 gigabyte memory overhead. And to enable this, we really focus on PEFT methods with ROSA. And ROSA is a sort of parameter-efficient fine-tuning method developed by collaborators. And we really show that this is able to give you good quality whilst keeping the memory overhead low. And in the second scenario, we push this far lower in that we push the floor to 15 gigabytes. And this is basically using the same PEFT methods with additional quantization tricks on top of it to make sure that the memory footprint is even lower to make it much more accessible. So this is just on a note on the process to actually produce the Panza models. Now, diving into the experiments, we start with RQ0 because we are computer scientists. But the first thing that I want to note is that generally, any metric for personalization, I think when you start investing your time into this field and studying it, you realize that the metrics themselves are not well defined. And I think this is partly from a historical thing. So I guess in the old days of NLP, pre-transformers, a lot of the tasks that were used to measure success on NLP tasks was machine translation, where you were basically trying to create a one-on-one copy of your reference and target text. Or it was summarization, where you took very long prompts and you were tasked to create something short. Now, in these two instances, we view that the point of this like LLM generation or personalized LLM generation is the exact opposite. Typically, your prompt is going to be much shorter and your email response is going to be much longer. And what we basically see that traditional metrics like BLUE, so coming from the machine translation community, which is like a precision-based n-gram matching score, and ROUGE being the recall equivalent, only take you so far in determining like how good your personalization are. So of course, n-gram matching is good to an extent, but they don't allow for a lot of things like personalization or creativity, and they don't really capture the gist of whether you've generated a coherent and a well-personalized output. In our case, we actually found that a good combination comes with BLUE and the MAUVE scores, where MAUVE is a score that maps, basically matches the similarity between two output distributions. And these two metrics work really well for us. And we found that during our experiments, using these two metrics have a high correlation between the quality of the model that the user gave. And it's actually using these two metrics in concert that allows us to develop these models because, of course, we can't allow or can't rely on user studies to guide our hyperparameter search. I mean, it would just be very expensive, even though it may be the most optimal thing to do. So this is just a first thing on metrics to keep in mind and why we report BLUE and MAUVE scores consistently throughout our paper. Now, going into the first point that I want to drive home from the experiments is that prompt engineering itself is really not enough. And we see this throughout our experiments. So observing figure 2 on the left, we see that in the case of having pre-trained models, so no fine-tuning at all, or pre-trained with RAG, so giving it additional context, gives no benefit or marginal benefit to the BLUE score, where MAUVE is basically like not present at all. You have not been able to do any style transfer. And this sort of counteracts these views that, oh, I can just use the API and I can pin all of my style constraints that I need into the prompt, and I'll let the LLM do the work for me. What we see consistently that whether you're using full fine-tuning, ROSA as a PEFT method or LoRa as a PEFT method, this is really what will drive home the performance by increasing both the BLUE score and the MAUVE score simultaneously to give a model, at least in this metric world, that is of a much higher quality. Then complemented with figure 3 on the right, we see that adding additional context either at inference time through RAG or during training with RAF techniques, of course, can give you a slight boost of giving you something that has better context, but it's really this thing that you need to train the model at some point to alter the weights such that it can adapt to your own style. And this is, I guess, the entire crux of everything, of why it is not just as simple as creating a good prompt and then you can go for it. Now, once we've established this, we see that once you've trained the models, observing figure 4 here on the left, the style is actually distinct. So here, what we're comparing is for each user, we're comparing the trained samples that were used to train the model versus the test samples that the model generated and comparing their MORV scores. So basically the output language distributions that they have. And we view consistently that the on-diagonal elements show us that for every user, you're quite accurately adapting to the style. And I mean, in the case of David, the David character in our studies, this was like perfect. And this is at varying degrees for the different users. But what's also encouraging is that the off-diagonals are very different, meaning that if you compare two users that have very different style, this is actually reflected in the models that you're producing. So this is very good from a metric point of view, and it was showing us that this personalization was indeed true. Then going on to figure 5, we actually see that this process is incredibly sample efficient. So viewing the blue and mauve metrics on the top and bottom respectively, we see that after, say, 75 emails, you completely saturate the growth of the metric, and feeding in more emails and giving more training data doesn't actually help the specialization in any way. So this sort of gives us a case that, okay, great, this personalization is very cool because it is cheap from both a hardware perspective, given that we've set it up with parameter efficient methods and quantization, but we actually don't need a lot of data, and I don't have to accumulate 200,000 unique email samples for myself. I can do it with a couple that I can gather in a very little time on my laptop. So this was really great, and it shows that this personalization is quite efficient and will be effective to give benefit to users. Now, going beyond the machine learning metrics, we actually started conducting a user study to see whether these sort of beliefs in the metrics showing that we've transferred the style effectively translate into something that users would derive benefit from. So the first thing where we wanted to measure this was this user study on usefulness, where we gave users who have trained their own LLMs, so with their own Panza models, with Rosa fine-tuning, and a Llama model with RAG. And we wanted them to rank the outputs from these models in a domain where it is fixed, so like general open class questions, or their own prompts where the prompts were selected to be very similar to what they themselves would have received or generated as emails. And across the board, looking at the average score, we see that Panza models consistently help and improve the score over the base LLM. And this is very important, and it shows that even though the style has transferred clearly based on the metrics, these models are actually more useful for the individuals for whom the models were produced. And we generally see that this usefulness can even be more pronounced in regimes where the task is in own, meaning the emails are ones that you will likely reply to or the ones that you have received. Then the second thing we wanted to detect is recognizability, meaning that if you got, say, 4 email samples, one from a Llama model, but of course the person evaluating them doesn't know from whom the samples received. So one was from a Llama model, one was from Jeff, a control user, and then the 2 subjects were individuals acquainted with one another so that you could have this like personal identifiability. And we basically asked them, can you match the generation to the character that would have generated them? And we see that across the board, users are routinely able to identify the prompt or the response correctly to the individual that was generated. So this was more pronounced for Llama, of course, because the LLM generation is very, very, very obvious and had really long prose. And I think this is not a surprise. Then Jeff was the next category over. And then finally, we saw that, of course, this is greatly above random chance for subject 1 and subject 2. But we hypothesized that the reason there was a lot of confusion between these two individuals because the two individuals knew one another and they were selected in a professional context, meaning they already had a language that was likely revolving around the same diction and the same vocabulary choice. So the distinction was not as obvious had we really separated these two individuals. But nevertheless, we see that this recognizability portion is really happening. The final one that we decided to study with users was this question of deception or suspicion, where we asked individuals that given a collection of emails, which of these would you mark as spam or suspicious? Now, we see for genuine emails in the first row, on average, 24% of them were marked as suspicious. And we believe that this is because we primed the individuals to be generally more careful of the responses that they were reading. But the interesting thing is that if you compare the genuine emails to the Panza L or Panza S, meaning the size of how many samples were packed into this model, we see that they're very, very close to sort of the same level of genuineness or suspiciousness as a real email produced by the author. And this shows that, of course, this now has a realistic style component that we've matched, but also we've managed to convince users that the Panza-generated emails, so things that are still LLM generation, that they're human-generated. And we see that this is miles apart from just using a base llama model where routinely, even greater than random guessing, you were going to flag this response as suspicious, which is, it's, I think, very close to what we see in the real world when you're reading LLM-generated text. Now, at this point, I actually want to take a step back a bit and say, this reality that I've just presented here, if we pack some of the results together, this is very scary for AI safety. And the reason that this is so is that modern technologies has really unlocked a very potent combination. So if we combine, firstly, the sample efficiency point, it actually means that I don't need to invest a lot of time into getting data to sort of use this personalization for a nefarious purpose. I can go onto, say, Twitter, scrape a couple of responses for an individual that I want to impersonate, and I'm done, given the fact that I can do this personalization in less than 100 email samples. Of course, the domain differs, but I think the same conclusions would transfer. The second point is that, as we showed here today, that this personalization and inference point of view is really not rocket science anymore. So even the most non-technical individual could follow some to-do document of downloading the latest fine-tuning framework, fine-tuning a model on some email samples that they've collected, and then they effectively get a personalized model for free. And in a world where we only have good actors, this is fine, right? Because everyone will use this for really good purposes to produce their emails, say. But what does it mean in a world where we have obvious bad actors and who are going to view this technology as an opportunity for exploitation? So the point that we are making, and this is prevalent more in our position paper, is that these efficient and personalized LLMs really exacerbate current attack vectors that we see in AI safety. And what we also make the claim is that this textual domain is perhaps more dangerous than I think what the domains that people associate with AI safety. For example, when I generate an AI video or an AI image, it is more often than not, I'm able to distinguish very quickly that this is in fact AI generated. So we have very famous examples where we have, an additional appendage on a hand, or we have, the Will Smith spaghetti eating meme, which is oftentimes a point of comedy. But text doesn't have this quality. It is just black and white characters on a page. And it's very difficult, unless you infer the style very well, to tell what is fake and what is not, and what is LLM generated and what is real. And we think that the textual domain is really, really having this quality. And the domains in which we see that, we give examples of a couple of these attack vectors, and we really see this causing issues in phishing, for example, where instead of just sending a random email and saying, oh, I'm someone that needs urgent help, please can you wire me $1 billion to this remote offshore account in the Canary Islands, you can actually spend a bit of time as an attacker to create something that is much more human and much more personalized to the individual you're trying to sort of fraud. And I think that the phishing attacks themselves will probably increase in frequency, but that's not the problem. The problem is that they will increase in their success ratio, where this human component, which will actually trigger a person to believing in the phishing attack, will actually will kick off, and we'll see a greater increase. Sort of the flip side is that we can see a very similar thing in character assassination, where individuals can take your email samples online and pretend to masquerade as you and sort of damage your professional reputation. Say if they know that you're employed by a company, for example, Google, and they post really condemning views about the company, even though this is not you doing it. The output is very, very convincing, because your colleagues will say, wow, that style really, really does sound like Andrej. Like, this is really bad. The final point that we also mentioned in this position paper was this argument of scholastic dishonesty, where I think using AI in education generally is a pretty good idea because of the personalization, how it can help individuals learn. But there's also this risk where individuals will take LLMs, generate entire outputs of academic assignments, and post it as if they were their own. And now we're currently in a place where this is good, because you can feed it into an AI text detector and it will come up true. Or if you spend a bit of time looking at it, you will see that it's LLM generated. But if this personalization gets to a point where it's so well done that it preserves the quality of the output, but completely masks the style, there is almost no hope of sort of detecting these AI-generated tests. This was, of course, in the academic environment, but it could be in other environments, of course. And the reason why we see this being a problem is that this textual domain is not covered by legal frameworks at all. So, for example, in the International AI Safety Report, the textual domain is alluded to, but there is a very, very, very big focus on the video, the audio, and the image element. And this sort of the textual domain is an afterthought, and we think it shouldn't be. And the models themselves really do not safeguard against these sort of qualities. I think many people have managed to go online to their favorite AI provider and perhaps even zero shot, or after a couple of prompt turns, they can really convince their LLM to output something that they shouldn't. And we give a couple of examples of this in the position paper. And now it comes to the question of what should we do to address this? And our position paper makes sort of these points that we should do. So the first thing is that we need more research into model safety. And I think this alignment direction is really good, but we need something that is a lot more robust. So something that I can't just prompt the model a couple of times or prompt it in a specific way and I'll override its safety, or methods that there's been research where you can take a couple of email samples and I can completely destroy the internal alignment of the model while preserving its quality. So the safety, while it should be there, it shouldn't be so easily destroyed. The second point, and I guess this is where Panza falls in, is that we need to have a better understanding of how feasible and how far LLM text personalization takes us. So of course, this was done on emails, but if we want to truly understand how impactful this needs to be, we need to really branch out into different domains and different use cases to understand how far it goes. Then a third point is that we need to figure out a way of how to sort of attribute and watermark LLM usage, because as was the case with Panza, this can be typically done in a completely anonymous way. A user can download a model from Hugging Face that is open weights, fine-tune the model, and start performing inference, but we have no way of attributing which LLM outputs belong to each user, nor which type of model they used. Now, it is not entirely clear whether there is a machine learning solution that is machine learning native, or we need other computer science disciplines to interact with the machine learning community to safeguard against this. But it is definitely the case that we need some way of auditing sort of the usage of open source language models. And the final point, I guess, is the least surprising of the four, is that we really want to encourage policymakers and people who have influence in the creation of legal frameworks to put the textual domain along with the other domains of sort of foundation model generation as first-class citizens when talking about these AI safety issues that might come out. Now, just to conclude and wrap up the presentation, even though like these risks in text generation generally do exist and we are sort of aware of them, I think this does not trump the point that Panza itself is a very useful technology. So provided it's used in the correct way, it can provide immense benefit. And I've really noticed this for myself when, when I was involved in the project and we were testing it. Panza is readily available, and I've linked the code repository there on GitHub at the top, and also the other 2 papers that are linked to it. And I really encourage you to use it for yourself. It is very simple to set up, and it doesn't, it takes a bit of time for you to wait to get the model trained. But beyond this, it's not incredibly involved, and it's quite robust given our extensive academic study of the setup. And the second thing is, whilst maybe some individuals in this call aren't people from this domain, I think we need to generally as a community, like the ML community at large, have an increased motivation and urgency into this AI safety research, particularly for the textual domain, because we see that these technologies are really advancing at a rapid rate, and we need to find mechanisms that are robust and that will transfer when personalization is in the question as well. Now, as a final point, I think as was mentioned early in the call, Panza is actually becoming a commercial entity now. And if you have any thoughts, ideas, feedback, or if you actually want to beta test the new products, please let Jen know. So her email is here. And I think this is very good. And I think I speak on behalf of Jen here, where any interaction with the framework is very helpful, because ultimately you want to cater to the technology for users that you're creating for. And without this, without further ado, I think this is the end of my presentation. Thank you for your attention, and I'm happy to now open the floor to questions and answer some if people have.